Geometry, Unit 4, Lesson 3. I can use the triangle inequality theorem to determine possible side lengths of a triangle. So we're going to pick some different side lengths and see if they can actually make a triangle. So let's try from, let's say, 1 to 6, a combination like 1, 2, and 6. Let's see if sides with those lengths can make a triangle. So here is 1, here's 2, and here's 6. And so if I put the 6 out like this, I put the 2 and I put the 1, is it going to make a triangle? And the answer is no, these aren't going to reach. And we can keep adjusting this. What happens if we tried 1, 3, 6? Let's take the 2 out. Let's put a 3 in. Well, it's getting closer, but not quite. So that's still no. We can change the 3 to a 4. It's getting close, but not quite. Still won't reach, won't close the triangle. 1, 4, 6 didn't work. What about 1, 5, 6? Here's the 5, here's the 1, and it's looking pretty good, right? Let's see. But as I try and close it, do you see how they only close when they make two parallel lines like that? It's not quite long enough, because if I try and open it up to make it a triangle, there's a gap, right? It opens. It won't work. So that's just no. We need a little bit longer. So maybe if I leave this right here, maybe if I make this a 2, let's get rid of that 1. Make it a 2, 5, 6. Let's see what happens now. Ah, there we go. We've made a triangle. Now that did not work, again, if you had the 1. If you had the 1, it looks like it's going to work, but as they close down, it doesn't make a triangle. But if you make it a 2, it can open up and actually make a triangle. So you can try some other combinations. Maybe if we bring 3 into this, yep, that still works. So let's see. 3, 5, 6, these are both yes. And maybe if you tried 4 or 5, all of those are going to work. So if you'll notice, whatever the longest side is, your two smallest sides have to add up to be bigger than the third. Again, the two smallest sides, if you add them up, have to be bigger than the third. If you add them and they're equal, in this case, the longest 6, this is 1 and this is 5, if you add them and they're equal, you don't make a triangle. You just make the thing is the same long length as the third. So they can't add up to be equal to, they have to add up to actually be bigger. And in this case, there we go. If this is 6, this is 5, and this is 2, finally 2 plus 5 is 7, that's bigger than 6. Two smallest must sum up to be bigger than the third. This is called the triangle inequality theorem. So if I come down here, I can say the third side, or I could just say the longest. The sum of the two smallest sides must be greater than the third side, or the longest side. And what kind of reasoning did we do here with a bunch of examples to look for a pattern? Inductive reasoning. because we used examples to find a pattern, and it might not be true, but it's possible that it's true. And we can confirm, though, that it is true based on definitions. So it's inductive reasoning because we used examples to find a pattern. Okay, sum of the two smallest must be bigger than the third side, the longest. So let's go take a look over here for a second. I'm going to try this one guided practice problem down here. Can these following sides make a triangle? You can hit pause and try and reason it out, but this is me doing it now. Let me find the two smallest. Here they are. So I'm going to go do 4 plus 5, and is that greater than the longest, 9? In this case, 9 is not greater than 9. It needs to be bigger. This is equal. Therefore, not a triangle. That's how you can test it out. Okay, let's really quickly take a look at this last part. What is the range? So if I give you two sides, can you tell me what are the possible measures for the third side? So for example, if I give you 2 and 5, these right here, here's 5, here's 2, would 1 work to make the triangle? No. So I put no, because look, what's 2 plus 1? It's 3, and 3 is not bigger than 5. Does 2 plus 2 work? Nope, it's not going to close and make a triangle. 2 plus 2, the two smallest, that's not bigger than 5. So that won't make a triangle. And I can keep testing this. I've put a 3 here. 3 plus 2 is not bigger than 5. 4 plus 2 is finally bigger than 5. And you see what happens when we get that. It makes a triangle. 4 plus 2 is 6, which is bigger than 5. So that did work. That's a yes. And then you can keep checking. 2 plus 5, yes, that's bigger than 5. But notice if you bring 6 into this, okay, we start making an obtuse triangle now. 2 plus 6 works, but you see how 6 now is now the longest? So these are the two smallest, so I'm going to compare those. 2 plus 5 is bigger than 6. You see the one that I've been putting in now is over on the right side because I have to look at the two smallest. So 2 plus 5 is bigger than 6. That's yes, it'll make a triangle. But as soon as I go to a 7, if you put a 7 in here, it wouldn't reach because 2 plus 5 is equal to 7. It's not bigger. So these are the three whole number possibilities for the third side. 4, 5, and 6. They're the ones that make the triangle. Again, you can keep testing by looking at the two smallest sides and adding them up and making sure it's bigger than the third side. However, there's a way to look at not just whole numbers like 4, 5, 6, but 4.1, 4.2, etc. And the way to do that is to take the two sides you're given and to subtract them on one end and add them on the other end. And if you do that, 5 minus 2 is 3, 5 plus 2 is 7. Anything between 3 and 7 will work. 3.1, 3.2, 3.3, those all work. 6.9, 6.8, those all work. You just need a little bit more, so when you add them up, it works. For example, let's try 3.1 and 2. Is that bigger than 5? 3.1 and 2 is 5.1. Yeah, that's bigger than 5, but just barely. So the two smallest added up were bigger than the third. You can try some of these on your own. You can hit pause and try with 1 and 6. What are the whole numbers for the third side that's going to make this a triangle? And you can also try and get the range. Okay, here I go. So 1 and 6, for example, I might try, if I pick a third side, how about, I'm going to try just 4. Does 4 work? Well, let's find out. 1 plus 4, is that bigger than 6? These are my two smallest. 5 is not bigger than 6, so no. What about 5? Okay, 1 plus 5, is that bigger than 6? Nope, it's not. What about 6? 1 plus 6, is that bigger than 6? Yes, that does work. What about 7? Okay, 1 plus 6, is that going to be bigger than 7? And in this case, no, it's not true. So the main number here that's going to work will be 6. 6 is the whole number that's going to work. And if you do the adding and subtracting idea here, you've got 6 minus 1 and 6 plus 1. 6 minus 1, 6 plus 1. That gives you a 5. That gives you a 7. The numbers for the third side to make a triangle have to be between 5 and 7. Have to be. 5.1, 5.2, all the way up to 6.8, 6.9. That'll work. So if we come down here to find the range, you take the difference in the two given sides, okay? And the sum of the two given sides. Third side is in the middle. So check these out down here. What's the largest possible number, third side, that will make a triangle here? Well, to figure that out, I actually should answer number 3. What's the range of possible numbers? Okay, let's do the difference. And let's do the sum. That's going to be 3. And that's going to be 25. We have to use a number between 3 and 25. You could take straws out, but that's what's going to work. So the last thing now is if you come over here, what's the largest possible whole number? Well, is 25 going to work? No, 25 is not less than 25. 24 is the biggest number you can put in here that's a whole number. So 24 will work based on this. What's the smallest possible whole number that's going to make this work? 4. Not 3, because 3 is not bigger than 3, but 4. That's how to find the range, to find the third possible side for a triangle given two sides. Good luck.